6.1. Evaluate nth roots and use rational exponents. So what does the nth root mean? We know square roots and cube roots. We can keep going up to say like fourth roots, fifth roots, and onwards. So we know that an nth root of a is for an integer greater than 1. If b to the n equals a, then b is an nth root of a. So let's say 2 cubed, 2 times 2 is 4, times 2 is 8. So 2 is a cubic or third root of 8. Cubic root of 8. Now the index of a radical. Index is what root number it is. And it's written as, if you have a in there, the index would be the n up there. So if we have 4 here, my 2 times 2 is 4, times 2 is 8, times 2 is 16. So the fourth root of 16 equals 2. We can take out or simplify this by taking out in this group number. So we could say 2 times 2 times 2 times 2, and since we had a group of 4 2's, we could say that the answer would be 2 then. Okay, real nth roots of a. Let n be an integer greater than 1, and let a be a real number. If n is an even integer, and a is less than 0, then we have no nth roots. So, let's see. Let me see if I can write an example of this. This sounds really confusing, doesn't it? But it's not. Let a be a real number. So, if negative 3, what is the fourth root of negative 3? Well, there's nothing that we can take an even root of a negative number. It would be imaginary, right? So that is where we're getting the no real nth roots. But if it's odd, then we can have it as a to the 1 over n. So if we have the squared root of negative 9, or not squared, cubic root of, let me try that one again. Let's not have negative 9. Let's do something that'll be easy for us. So negative 8. Since this is odd and the number is less than 0, it's a negative number in here, then we can say that it does have a nth root. It's negative 2. So you have to watch those negative numbers inside and make sure that it's an odd root. Now, if a is 0, then of course the root is 0. And if it's odd, it's still 0, isn't it? So the fifth root of 0 is 0. If it's greater than 0, then we have plus and minus two real nth roots. So we can write it as plus and minus a to the 1 over n. And then for odds, it's still a to the 1 over n, but this time we don't need the minus. So if we have the cubic root of 8, it can't be negative 2. It has to be positive 2. Right? But if we have the square root of 9, then we can have plus and minus 3. Okay? Because it's a squared. Even integers have to have that plus and minus there. So let's look at examples. Find the indicated real nth root of a. Okay, we have, let's write it in a system that you can understand. The a is inside the radical sign, and the nth is the root number out here. So, what thing can we multiply by itself 3 times and get negative 64? And that is only negative 4. So it is negative 4. Now, what about this one? 729 to the 6th? Then it's a even number, so this is where we have to get our plus and minus. So we can put in our calculator like this and say 729 caret parentheses 1 divided by 6. And then the calculator will give you 3. And then we know to go back and put a plus or minus 3 since it's even. Don't forget the plus and minus. Okay, so here is your checkpoints. Number 1 is even root, so your final answer will have a plus and minus. Number 2 is an odd root, so only going to have the positive version of it. Now, rational exponents. If you have a to the m over n, that really means the nth root of a to the m power. And so we can write it as the nth root of a like that. And then if we had the negative number, that just remember that doesn't mean an actually negative up there. It means a position marker, flip it underneath. And so that would be a to the nth root times m. We always take the root first, and then we use the exponent on it. So example 2. Evaluate 8 to the negative 4/3. So we can do it 2 different ways. We can do it in rational exponent form, or we can go back to radical versions. Either way works. So for rational exponents, we can say that is 1 over 8 to the 4/3, or that is 1 over, and what's the cubic root of 8? 2 to the 4th, or that would be 1 over 16. Okay. Now the radical form, we can go 1 over 8 to the 4/3, start the same way, but then we change that 8 into a third to the 4th, and then we'll get the 1 over 2 to the 4th and 1 over 16. So it's just whatever way you tend to see first. I like this radical exponent way better just because it's easier for me. Example 3. Solve equations using nth roots. First thing you do is isolate the x, so we need to divide off the 2, and that would leave us with 729. And then we need to take the 6th root of both sides, a plus and minus the 6th root of 729. And that. Okay, example 4. The population P of a certain animal species after T months can be modeled by that equation, where C is the initial population. Find the population after 19 months if the initial population was 75. So you first need to write down your equation and then substitute for what you know. So 75 was our initial C. 21 and 19 was our months. Now, we need to solve it or use a calculator to solve it. Make sure you don't just say 75 times 1.21 up 19 thirds, because your calculator may go ahead and multiply the 75 times the 121. I would put it in double parentheses, or I would do this part first and say then times 75. Go ahead and do that on your calculator. Make sure you get about 250. Okay, and finish up the 3 checkpoints at the bottom and bring them tomorrow.